Good evening, students. Online class, can you hear me?
Yes, sir.
Okay. Okay. So today we will be looking at facility, location and layout. That is chapter 2.3, page number 41. Okay. Right. So what is a facility? So the definition of facility is, it is nothing but it is a setup for operation of an organization. Right. So it is a setup for operation of an organization. So what is an operation? So operation might be production of goods or it might be services, or rather it is rendering of services. Right. So a facility is nothing but it is a setup for the operation of an organization, that is production of goods or rendering of services. So this is a place where you produce your goods or you render your services. Okay. Yeah. So setup, what does a setup mean? So setup means nothing but where you know you have all of your machinery, you know, uh, utilities, manpower, labor, so this is a place where you have all of your amenities or all of your tools for your producing your goods or rendering of your services. So that is a facility. Right. Okay. Now location of a facility. Location is nothing but where your factory or your setup is located. So where should it be located? So now, what are the factors we must take into consideration while choosing a location, while choosing an optimum location? Right. So you are manufacturing some kind of goods or services, you're rendering some services. So what are the factors that you have to take into account so that you choose your optimum location? So the factors, they are broadly categorized into sourcing, markets, cost, social and political factors. Environment, competition, and you can say human capital. Right. Okay. So sourcing. So your location should be in such a place where you know the availability of your raw materials, your raw material, you should be able to see your raw material should be optimally reaching your factory premises, right? So it should be in a place where raw materials are abundantly available, or they can reach at the time you need them, right? So you should have proper transportation facilities available, so that they can reach your location at the optimum time, right? And markets is nothing but where you want to sell your product, right? So you should have accessibility to your markets. You should have easy accessibility to your markets, so you can reach your customers, or your customers, so where you can reach your customer base, reach your customer base, and your customers also should be able to reach you, right? So suppose if you are a service based organization, you know the customers also should be able to come to you, right? So yeah, and it should be cost. Cost is also a key aspect which you have to look at when you are choosing your location, because when it comes to raw material, or if when you are selling your goods, you are sending your product to your market, and if you are located, you know, very far away, so your transportation costs increase, right? So your transportation cost will increase. If transportation cost, or you know, setup cost, so all of this will increase. So if you buy a new machinery or a new capital item, and if that has to reach your factory premises, so if you are located far away, the transportation cost, again all of your capital cost also increase. So cost is also a major factor while you are looking at your location, right? And the social and political issues. So political, as in it should be very stable. You should have ample security, where your workforce feels secured, and and you have to look at your, you know, socio cultural integration. Yeah, so uh, your company, wherever it is, it should, it should not offend the culture of that local area, right? And environmental. So if you see, environmental conditions nowadays, you know, there are a lot of environmental policies, so where you have to have them in a favorable environmental, so your green policies, and you know, your pollution control and everything. So you should have a law or a place where all of these are meeting the policies, right? And obviously human and competition. So your location can also be a competition advantage, right? So if you can access the markets faster than your competition, so your location is helping you there, right? If this competitive advantage can be achieved by a proper optimum location, if raw materials are reaching faster and cheaper to you than your competition, so your cost of production will be less. So it can be a strategic advantage that way. And human capital also. So you need workers, right? You need workers, you need employees coming into your factory location. So now it should be easily accessible to them, and also you should be able to find skilled employees where your setup is, right? So otherwise your productivity will affect. So all of these things, it should not be very far away from the home. So if you're in a city and you are located somewhere outside, so every day you cannot ask your employees to travel 40 kilometers, 50 kilometers up and down, and then there'll be 2 3 hours of. So all of these things should be taken care of while making the right location decision, right? Okay. Now that was about location. So layout. What is a facility layout? Facility layout. Layout is nothing but a configuration of your facility. So what do you mean by a configuration? So configuration is something like how it is set up, right? So how is your facility set up? Okay, and if you are talking about a factory, so where all of your factory sections will be there. So suppose you are a furniture manufacturer, right? So you will have wood processing, right? And suppose assembly, and suppose painting and polishing. All of these are say different sections, right? And probably you will have finance or your support people, okay? And then you will have your warehouse to store your finished product, or you transport your finished product, okay? And then now you will also you will need to have cafeteria for your employees, right? Toilets, restrooms, or if it's a production, you will need to have your first aid providing facility. So all of this, how you are setting these up in your factory premises, right? So where everything goes. So how are you setting this up? So all of this configuration comes under facility layout, right? Again, so what are the factors that affect your layout? So what are your critical considerations when you are deciding about how to have a factory layout in an optimum position, right? So the factors influencing your layout would be the location, the machinery, your policies, managerial policies, the materials, and your products. Okay, so these are the factors which influence your layout. Okay, so location. So obviously the location plays a key factor in your layout. So if you are in a very huge city, so where the land is costly and your rents are costly, so you might probably have a small or a medium layout, right? So you want to probably optimize your cost on your rent, or uh, so you want to spend less amount, so you have budget restrictions. So all of that will affect the location and the machinery. Now suppose you are in a big huge manufacturing company where you have huge machineries, and you need big assembly plants, you need those cranes and all of those heavy lifting machineries, then that will definitely affect your layout, right? And your policies. So the manager policies or the company policies will also affect your layout, and material also. So if you have a lot of raw material, then probably in your layout you will need to have multiple checkpoints, and multiple loading and unloading stations, right? So multiple loading and unloading stations and all kind of material handling will be more. So that is also a critical factor. Okay, and obviously your product. So if you're manufacturing a product, every product will have a different facility. It will have a different process, right? So based on the product and the manufacturing of the product and the process of manufacturing, the process of manufacturing, so your layout will also change. So these are, I would say, key factors. Maybe not all the factors, but these are the key factors that will affect your layout design, the design of your layout. Yeah. Okay. Okay. Now we can look at types of layout. So you have a process layout, you have a product layout, you have fixed position layout, and you can have a mixed layout. So mixed layout, nothing but it can be a combination of one or more of these, right? So these are your types of layout. Okay. Okay. Coming to process layout. Process layout is also called as functional layout. Okay. So what is process layout or functional layout? Functional layout is nothing but, so a layout, your facility layout will have different kinds of functions, right? So say suppose you are you are into furniture manufacture, right? So let us take the example of your furniture manufacturer, right? Or let us take a car manufacturer. Okay, so let us say you are manufacturing a car, right? So there are many functions. So if we talk about the functions, okay, so there would be you know engine engine manufacture, right? There would be chassis manufacture, okay, and then there will be probably your seats and other interiors manufacturers, right? Then there would be your electronic any electronic assembly line, and then you'll have your main assembly, right? And then probably you'll have painting, denting, then you will have your testing, then probably you'll have fueling. So in a factory, based on these functions, you will have a setup. So if this is your factory, so you might have engine, chassis, okay, and then probably fitting, okay, and then the electronics and probably your assembly, right? And yeah, so you'll have your painting. So you will have, based on the function of that particular department, it will be segregated into, uh, you will have a function based layout. So there is no necessary rule saying that the process should fall like this and it should come out. So it is not like it will go here first, it can go here second, third, fourth. No, it is not like that. So it can go to engine first, and then probably electric second, and then you can have your chassis, and then painting and maybe assembly. So, and it can again move front and back, and there's no hard and fast rule saying that it should flow like this. So this is based on the functions, right? So what is the advantage of this type of a layout is, say, because you will have experts in each of the departments, so it will be easy for the supervision and it will be easy for the labor. So if you have a expert in engine, so if this is a separate section, so he can easily monitor what is going on in his particular section, right? So mainly that is the advantage, but the disadvantage is because there is no process. It can go from once, twice, and thrice also from the same function. It is not very cost effective. So the cost might be ineffective because it keeps rotating. And suppose it should go to assembly 3 times, and this is your furniture, the interior of the car, and if your assembly is somewhere far away in your facility, then you're this thing, so there might be a cost ineffectiveness. So if the facility is a little bit far and it has to go there 3 times and 4 times for one vehicle, so it is not very cost effective. So that is one of the disadvantage of this process or functional layout. Now product layout. So product layout is nothing but the way the goods is manufactured. So you might have several function processes in each, but you will have a single flow. So here your raw material will go in, and then it will flow through the individual processes, and here you will get your finished product. Right. So this is this is a product layout. So taking the example of a furniture, or maybe a cloths manufacturer or something. So here you get all your textile, cloth material or something, and here maybe they'll probably cut it or size it, okay, and here probably they will have some design on the cloths or something, design on the material, right? And here probably you will have stitching and or fitting, and then you will get your finished product out, right? So this is your product layout. So this is cost efficient, and this moves according to the process. So this is designed according to the process order. I mean, so how the processing takes place, the assembly line or the facility is designed in such a way, right? So this is your product layout. And coming to the next is fixed position layout. Okay, so now this is for this kind of a layout is for huge equipment. So huge, very heavy and huge capital equipment. Say probably ships or trains. So things like that. So there, what happens? You will have a fixed point, where initially the shipbuilding takes place. So say the shipbuilding takes place here. So all your raw materials come in here, your labor comes in here, you know, and everything needed for the ship to get completed, it comes to the place where the ship is being built, because a ship is huge, right? So you cannot keep moving it around in a factory. It is not possible, or this happens in your space organization also. So ISRO and all. So ISRO, NASA, if you take, so how they build their spacecraft, they do that. So they get to a point and then they build their spacecraft. Probably the spacecraft, requires small, assembly. It might require satellite, antennas or, solar panels and all of these things. So all of these things come to one point and then they assemble and they build it here, and this will not be very far from your launch site. Okay, and then they just take it to the launch site and then they launch it, because you cannot transport such huge equipment very far, right? It is not very feasible, and it will take very effort also, not only cost, but also it is not very easy to transport such big things for large amount of distances, right? So this is called your fixed position layout. Fine. So mixed layout is nothing but it is just a mix of these two. So 50% of your factory can be of process, and then it can move in a this can be functional, and then it can be product. So 50% can rotate like that, and then after that it follows a certain process and it comes out. So it can be a combination of these two, right? Yeah. Okay, in page number 53, there's importance of layout, right? So you can give this a reading on your own. Okay, you can see what is the importance of a layout. Okay. Now let us go to the problem. We will see illustration 11. Okay. This page number 54. Yeah. So the present layout is shown in the figure. The manager of a department is intending to interchange the department C and F in the present layout. The handling frequencies between the departments is given. All the departments are of the same size and configuration. The material handling cost per unit length travel between departments is the same. Okay. What will be the effect of interchange of departments of C and F? So he has given us one factory setup or one facility setup, right? So there are 6 departments. A, B, C, D, E, and F. There are 6 departments, and he has given the handling frequencies. So if you look at this table, so he says from these are the 6 departments: A, B, C, D, E, F. Okay. Yeah. So there will be nothing from 8. So this will not be there, right? Sorry. Okay. So A to B, there is no handling frequency. So A to C, your goods probably move 90 times, right? And D 160 times, 50 times, and 0. So 70, 100, and 130. Right. 20 and 0. This is 180 and 10 and 40. If there's nothing. Okay. So this is your frequency. And this is your setup. And he says all the departments are of the same size and configuration. The material handling cost per unit length travel between the departments is same. So that means, so if we say a good traveling from A to B, it will cost you 1 rupee. So A to C will cost you 1 rupee, and A to D, so it has to take 2 steps, 1 and 2, right? So the length is 2. So this will cost you 2, and A to E again will cost you 1 and 2, right? So that way, right? So that is the distance. So distance from one department to the other department. Okay. So we can put a matrix here, B, C, D, E, F. So first we will have to calculate the total cost based on the frequency of your current setup, because he says what will be the effect of interchange of departments C and F in the layout, right? So this is your initial setup and this is your final setup. So in your final setup it will be A, B, F, D, E and C. So we will have to calculate the cost, right? So we can have the distance between each department. So we have to, for the initial setup. So let us calculate for the initial setup. Okay, so let us calculate the distance now. So from A to A there will be no distance. From A to B it is 1. A to C is 1. A to D is 2. Right. A to E is 2. And A to F is 1, 2, 3. Right. Right. So similarly from B to A it will be 1. And B to B there will be no distance. You have to see B to C will be 2, B to D is 1, B to E is 2, and B to E is 3. Sorry, I'm sorry, my mistake here. Yeah, these two. Yeah. B to D is 1, B to E is 3, right? 1, 2 and 3. Yeah. And B to F is 2. Similarly from C to A is 1, C to B is 2, C to C will not be there, and C to D is 1, C to E is 1, and C to F is 2. Okay? From D. So D to A is 2, D to B is 1, D to C is 1, D to D will not be there, D to E is 2, and D to F is 1. From E, so we have to just take E to F because rest all is covered. They'll repeat, right? So E to F is 1 and F is done. So F will not be there. So you understood this? The distance? Have we got the distance? Any questions? So if you want to see F to A, it is the same as 3, right? So वहाँ से देखना या याद से देखना, there is no difference. So similarly, F to B is also the same way. Right. Okay. Now coming to the cost. Now we have to, see the cost. So I'll just replace this table here, so it will be easy. So if you see, you just multiply the amount with the frequency. That will give you the cost, right? So 0 into 1 is 0, there is no need. So 90 into 1. Okay. And 160 into 2. 50 into 2. And this is not required. So similarly, from B to C, it is 70 into 2. Okay. And 100 into 3. And 130 into 2. Correct? Similarly, from C to D, the distance is 1. So this is into 1. D to E, it is 180 into 2. And D to F, it is into 1. Okay. So E to F, it is into 1. And F is empty. There is no frequency given. Right. So if you sum the whole of this, so if you take the total, yeah. So this is 90 plus 320 plus 100, right? This will be 510. This is 700, 20, 370, 40, 1640. So this is the total cost based on the frequency and the distance. And this is for our the initial setup. So similarly, for the final setup, we will have to work out the distance and then multiply with the cost. Okay. So I will just replace the table here. Okay. Yeah. So here, so A, B, B, C, D, E and F. Okay. Coming to the distance, A to B will be 1, A to C is 3, A to D is 2, A to E is 2, A to F is 1, right. B to A will be the same 1, B to C is 2, B to D is 1, B to E is 3, and B to F is 2. So C to A is 3 and C to B is 2. C to D will be 1. C to E will be 2. C to F is 1. Right. Is it sufficient? So no, we need D to E. D to E is 2. C to E is 1, is it? Okay, sorry. C to F will be 2. Correct. Yeah, now D to F will be 1. And E to F will be 1. Yeah, that's enough for us, right? Okay. Now if we calculate, this is 50, right? 70, 0 and 130. This is 10, 40. Okay. Similarly, now we can multiply with the distance, with the new distances, right? So A to C will be into 3, 1 into 2 and into 2. Into 2. This is into 3, is it? B to E? Yeah. Into 3 into 2. C to D will be 1 and D to E will be into 2 and into 1 and E will be into 1. So now what will be the new totals here? This is 690, 700, 20, 370 and 40. So this is coming to 1820. So which is increasing your cost, right? In the initial setup, we were at 1640. Now because of interchanging the position C and F, now we have increased the cost to 1820. So this is not a desirable modification, right? Is this clear? Yeah. Okay. So the next problem, he gives us a setup E, A, B, C, F and D. So we can calculate the distances. He also gives us a frequency, right? So let us write the frequency. So A to B is 8, 3, 9 and 5. It's 3, 8, 9, 3 and 3. Okay. Okay. And he has given us E, A, B, C, F and D. Okay. Now here he doesn't say that he will interchange departments. He says health and safety regulatory departments E and F. So E and F. E and F remain at their current positions. So, and he says, can the layout be improved? Also evaluate using load distance. So load distance is nothing but what we have done in the previous problem. That is the distance into the number of frequency, right? It is the same. So he says these two are fixed and you are free to adjust the position of all of the four other departments so you can have the maximum efficiency. Okay, so that is what he says. Okay, so how to approach this problem? So we can, so E and F departments are going to be fixed, right? So let us see who is having the most number of frequency with both of these departments. Okay, so if you see here E and F combination frequency, A has 14, C has, this has 0, this has 17, 0 and 0, right? Oh sorry, E and F, this is 3 and 3, 3 and 3. Yeah. So C has the maximum interactions with both E and F together, right? So it would be best if we have the minimum distance of C from E and F, right? So that would be E and F, and I have 4 positions vacant, right? So where can I keep C? So if C is here, it will have a distance of 1 and 1 with E and F, right? But if I keep C here, here or here, it will have 1 here and it will have 3 with F. It will have 2 each with E and F. And here it will have similarly 3 and 1 with E and F. Correct? So we can keep C in the middle of E and F. So that is the most logical, right? Okay. So now we have seen the most interaction. Now let us see what is the next highest, right? So E interacts with A 9 times. So A interacts with E 9 times and B 8 times. So we can put A here because this is the next highest. Oh, we have F also. Oh, this is done, right? C is done. So there is no need to look at C. Okay, so we can place A here. So this distance is 1, right? Because F is fixed. So now we have to place what all? So we are done with A, we are done with E and F. So, and we are done with C. So B and D. So D interacts with F 3 times and B interacts with D 3 times. So we can put D here, this will be 1, and B here. Right? This is logical? Yeah. And you can calculate the total cost. Okay, so you can calculate the initial cost in this setup in the similar way by giving distances, and this setup by the new distances, and you can see whether we have achieved any improvement in the layout or not. So he has already done that. You can also try on your own. So in the initial setup the cost was 92, and in the new setup the cost is 67. Okay, yeah. Okay, coming to the next problem. You have 6 departments. Okay. you have d1, d2, d3, d4, d5 and d6. Okay, he has not connected between d2 and d5, but you can assume the distance between d2 and d5 is also 1, so you can have that one connection. Okay. Okay, and now he has given a frequency table. Okay, so if you look at the table in page number 58, I think it would be best if we stop here, because this is a big problem. It will take some time. We will continue this problem in the next class. Okay, in the meanwhile, you can give it a try for yourself, but we will discuss this problem in the next class. Okay, we will stop it here today. Yeah. Any questions? Okay.